Hello everyone and welcome to this video on different types of expressions in Python. Expressions are a fundamental concept in Python and are used extensively in programming. In this video, we will discuss the various types of expressions in Python, their syntax and examples. The first type of expression in Python is arithmetic expression. These expressions are used to perform arithmetic operations such as addition, subtraction, multiplication, and division. For example, the expression 5 plus 3 is an arithmetic expression that adds two numbers together. Let's see an example. In this example, we first define two variables x and y with values of 5 and 3. We then add them together using the plus operator and assign the result to a new variable z. Finally, we print the value of z, which should be 8. Let's look at a second example for this. Here, we have an arithmetic expression involving addition, multiplication, subtraction, and division. The expression is evaluated following the order of operations, and the result is printed. In this, it will be 9 because the multiplication takes place first followed by the division, then addition and subtractions. Let's now talk about integral and floating expressions. Python supports both integral and floating point numbers. Let's explore how expressions work with these data types. This example is demonstrating the difference between integral division and floating point division in Python. In the first expression, the operator performs integral division, which divides the operands and returns the quotient as an integer, discarding the remainder. The result of the first expression is 3 because the quotient of the division is 3, and any fractional part is truncated. In the second expression, the operator performs floating point division, which divides the operands and returns the quotient as a floating point number, including the fractional part. The result of second expression is approximately 33335, as division involving floating point numbers yields a more precise result. The point of this example is to illustrate the difference in behavior between integral division and floating point division. It showcases how the choice of division operator can impact the result, depending on whether you need an integer quotient or a more precise floating point result. Okay, moving on to the logical expressions now. Logical expressions are used to compare two values and return a Boolean value, true or false, depending on whether the comparison is true or false. For example, the expression 5 less than 3 is a logical expression that compares whether 5 is less than 3. Let's see an example. In this example, we define two variables x and y with values of 5 and 3. We then compare them using the less than operator, which returns a Boolean value indicating whether x is less than y. We assign this value to a new variable z and print its value, which should be false. Let me do one more example of this expression. In this scenario, we are using logical expressions to evaluate the truth value of certain conditions. We first assign the Boolean value true to the variable is underscore true and false to the variable is underscore false. The expression is underscore true and not as underscore false is a logical expression that combines two conditions using the and not operators. The and operator returns true if both conditions are true, and the not operator negates the value of is underscore false, so it becomes true. Therefore, the result of the logical expression is true. The code then prints the result as, is the logical expression true? True. This example showcases the use of logical operators and not to evaluate conditions and obtain Boolean results based on the truth values of the involved variables or expressions. Now we move on to conditional expressions. Conditional expressions are used to evaluate a condition and return one value if the condition is true and another value if the condition is false. Let's create a scenario for that. In this code, we have a variable age that is assigned the value 25. We want to determine whether the person is an adult based on their age. The conditional expression true if age greater than or equal to 18, else false checks if the age is greater than or equal to 18. If it is, the expression evaluates to true. Otherwise, it evaluates to false. This is a concise way of expressing a simple if-else condition. The result of the conditional expression is stored in the variable is underscore adult, and it will be true if the age is greater than or equal to 18 and false otherwise. Finally, we print the result as is the person an adult, followed by the value of is underscore adult. In this case, we should get the statement to be true since the age is 25. This example demonstrates the use of a conditional expression to assign a value based on a condition, providing a more compact and readable alternative to an if-else statement. Next up is bitwise expressions. Bitwise expressions are used to perform bitwise operations on integers. These are the kind of expressions in which computations are performed at bit level. Let's take a look how that is done. In this example, we define two variables x and y with binary values of 101, which is equivalent to 5 in decimal, and 011, which is equivalent to 3 in decimal. We then use the AND operator to perform a bitwise AND operation on x and y. The result is a new binary value of 001, which is equivalent to 1 in decimal, which we print to the console. Bitwise expressions are commonly used in scenarios where you need to manipulate individual bits of binary representations or perform operations at a bit level. Finally, let's talk about combinational and multi-operator expressions and then finish off this lesson. Combinational expressions involve combining multiple operators to perform complex computations. Let's explore a couple of examples. We have two different types of expressions, a combinational expression and a multi-operator expression. Let's go through combinational example first. First, we have the value variable that is assigned the value of 7. The combinational expression, value plus 5, multiply by 2 to 3 is evaluated in a specific order according to the precedence of arithmetic operators. First, the addition operation value plus 5 is performed, resulting in 12. Then the multiplication operation 12 multiply by 2 is executed, resulting in 24. Finally, the subtraction operation 24 to 3 is performed, resulting in 21. The result of the combinational expression, 21, is then printed. Next, for the multi-operator expression. The value variable still holds the value of 7. The multi-operator expression, value greater than 5, and value less than 10, or value equals 20 is evaluated. First, the comparison value greater than 5 is evaluated, which is true since 7 is greater than 5. Then the comparison value less than 10 is evaluated, which is also true since 7 is less than 10. Next, the logical AND operator AND is applied to the two comparison results, resulting in true. Finally, the equality comparison value equals 20 is evaluated, which is false since 7 is not equal to 20. The logical OR operator OR is applied to the true and false results, resulting in true. The result of the multi-operator expression, true, is then printed. In summary, the code demonstrates the evaluation of a combinational expression and a multi-operator expression, showcasing how different operators and operands are combined to produce specific results. Let's wrap it up here. In this video, we discussed the 4 types of expressions in Python: arithmetic expressions, logical expressions, conditional expressions, and bitwise expressions. We covered the syntax and provided examples for each type of expression. Understanding these different types of expressions is essential for any Python programmer as they are used extensively in Python programming. We hope you found this video informative and useful. Let's catch up in the next lesson.